All right, physics fam, we are back and we've been learning about series circuits. So if you want to look at problem number 2 here from our homework practice, it says that you have a 10 Newton, sorry, not Newton, you have a 10 ohm resistor, a 20 ohm resistor, and a 30 ohm resistor connected in series and placed across the terminals of a 120 volt battery. So first part in A is that we want to draw out the schematic drawing of the circuit. Easily done. Since we have a series circuit, there is going to be only one path for electricity to go through. So I'm going to draw 3 different light bulbs in series. Notice that if the electricity starts here, it only has one pathway to go. All right, let me label up some things here. This will be resistor 1, resistor 2, and resistor 3. My 2s and 3s get a little troublesome, so I'm sorry about that. All right, the resistance on resistor 1 is 10 ohms, resistor 2 is 20 ohms, and resistor 3 is 30 ohms. And the voltage across the battery is going to be about 120 volts. Okay, so now we have our series circuit for our 3 resistors. Question number 1 asks, what is the equivalent resistance? Which is really just the total resistance. So we can write that as RT or REQ. All right, well, let's do that. If we want to know the total resistance, we just have to add up all the different resistors. So, as simple as it may seem, I'm going to add up my 10 ohms plus my 20 ohms plus my 30 ohms, and that will give me total resistance. The reason, as electricity flows through this circuit, as you go across more and more light bulbs, you get more and more resistance. So you just simply add them up. 20 plus 30 is 50, plus 10 is 60. So the total resistance, EQ, equivalent resistance, ends up being 60 ohms. Now letter C wants to know what is the current in the circuit. Now notice that it's not asking what are the individual currents. The reason for that is we know in a series circuit that the current is constant throughout. And the reason for that is as the electricity goes through the circuit, as it slows down more and more, eventually this last resistor is slowing down everybody and the line backs up. So the electrons behind it can't move faster than the electrons in front of it. And once the electricity flows through the circuit, all the electrons are moving at the same rate or the same current. So in a series circuit, current stays constant. To find that out, we are going to use Ohm's law, which is voltage is equal to current times resistance. Now we're going to use the total voltage since we're looking at the entire circuit, and we're going to use the entire resistance as well, the equivalent resistance. So let's plug that in. The battery is 120 volts, the current we don't know, and we just figured out that the total resistance is 60 ohms. Simple enough math there, 120 divided by 60 ends up getting you a current that is equal to 2. What is the unit for current? Don't forget, it's amps, so it's 2A. All right, working on letter D, I made some room for us. We want to know what is the voltage drop across each resistor. Since these are different light bulbs, they each have a different voltage. So V1, V2, and V3. And to do that, we'll just look at resistor 1, resistor 2, and resistor 3. All right, so let's do it. As you probably are already noticing, we like Ohm's law a lot. So we are going to use Ohm's law to find the value for the voltage drop at each individual light bulb. But we want to use the resistance at resistor 1 for voltage 1, resistance of resistor 2 at voltage 2, and resistance on resistor 3 for voltage 3. So V1, V2, V3. The nice thing we know is that current is constant throughout. So in all of these, I'm going to use 2 amps for my current value. The nice thing also is that resistance is given for each resistor, 10, 20, and 30. So I'm going to plug in 10, 20, and 30. All right? So now that we have that, all I need to do is solve for my voltages. Well, 20 is 2 times 10, so that's easy enough. That gives me a total of 20 volts. 2 times 20 right here is 40, so that gives me a total of 40 volts. And 2 times 30 is 60, which gives me a total of 60 volts. So if we look at the individual voltage drops, that means, and let me draw this path again, as we start at the beginning of the circuit, as the electricity goes through the circuit, voltage drops more and more until eventually voltage is 0 at the positive end of the battery. Why? Because electrons are high energy near the negative end and don't want to be there, so they flow to the other side. And as they do that, they lose potential energy, which means you have less potential difference, which is the same thing as saying less and less voltage. By the way, letter E is kind of an important thing. We want to know what's the total voltage drop. What we're really asking is, when you add these guys up, 20, 40, and 60, add them all up, do they end up adding up to the initial total voltage of 120? And the answer is yes. That's very important. After you go through all the voltage drops, all the individual voltages added up should equal to the beginning voltage of the battery. So that worked out. 120 volts by the battery, which was 120 volts to start with. All right, I erased some things up to clear some room for letter F, our final part of the problem. F asks, what is the power of the circuit? All right, so if we want to know the power of the circuit, there are many different equations to use, but my favorite and easiest, I think, is power is equal to current times voltage. All right, so P equals IV. So we can do that very easily by plugging in our current, which we know across the board is 2 amps, and also plugging in our voltage, which is 120 volts for the entire circuit. Well, 2 times 120 is 240. Don't forget, what are your units for power? It's W, or watts. So this series circuit allowed electricity to pass through only one path. Remember, if for some reason this light bulb right here was unplugged, you would have broke the circuit, meaning that electrons would never have been able to pass from side A to side B. Therefore, all 3 lights would have went out. That's the weakness with the series circuit. If one object comes off the circuit and breaks the circuit, nothing works because you no longer have that pull of electrons from the positive end. If it's not connected to the positive end, there's no way for that voltage or potential difference to be created. All right, so hopefully walking through this problem with you helped shine a little bit more light and helped you be a little bit more confident with series circuits. Of course, we're going to be working on labs, building them, but using, importantly, Ohm's law to figure out a lot of the relationships between the circuits. So best of luck. Don't just memorize, but try to understand how the circuit is working, and that in turn will help you understand the major difference between series circuits and what we'll do next, which is parallel circuits. Thanks, physics fam. Have a good one.